Hey guys, welcome to another awesome video. Naj Kazi here. Today's video is about SD-WAN or software defined WAN. In today's video, I'm gonna go deep into the topic of wide area network. You'll learn a ton. I spent over a decade of my life in the service provider realm, and at times it's probably gonna feel like you're drinking from a fire hose because I'm gonna throw it all at you. But hang in there. The good news is you can always go back and rewatch. And if you want to learn more about SDN or software defined networking, that's the previous video I did. So I'm going to provide the link down in the description below. And I am fired up. Let's roll the intro. Let's jump right into it. What is SD-WAN? SD-WAN stands for Software Defined Wide Area Network. What it does is it decouples hardware from software and it creates a virtual network overlay. And essentially it separates the control plane from the data plane. If you want to learn more about the separation of the control plane from the data plane, I highly recommend that you watch my previous video on software defined networking or SDN. I'll also provide a link down in the description below. What SD-WAN also gives us is a combination of different technologies that have existed for a very long time, but now we have the ability to kind of bring them together in a very clever way to create this next generation wide area network. So things like encrypted tunnels, IPsec and GRE, I mean, they've been around a long time, nothing earth-shattering there, right? They have existed for almost 2 decades. Routing protocols like OSPF and BGP, they've been around a long time as well. And various other network topologies that you can create. You can have point-to-point, partial mesh, full mesh. You can create whatever your heart desires from a network topology perspective because you're no longer bound to the type of circuits you have. You can now create virtual overlays. So it's a very exciting technology and a plethora of other things that you get with SD-WAN. And my goal today, guys, is to provide an SD-WAN overview from a high-level perspective and also from a vendor-neutral perspective, right? I don't want to make this a Cisco conversation or VMware conversation or a Silver Peak conversation. I want to talk about SD-WAN in general so you get the idea of what the technology is about. And I do plan on creating some additional videos in future on specific technologies like Cisco, Silver Peak, and others. There are 3 things that you get with SD-WAN, and I think these 3 attributes can pretty much cover what SD-WAN is about. First one being transport independence, second being it's cloud friendly, and third being it's simplified and secure. So let's look into the transport independent piece. To understand that, let's look at the SD-WAN architecture and the different components that make up the SD-WAN architecture. So in this design here, we have 2 sites, San Jose and New York. Let's assume each one has a single SD-WAN appliance. And what we call this SD-WAN appliance in general terms is SD-WAN Edge. These SD-WAN appliances or these edge devices end up communicating with the SD-WAN orchestrator or the SD-WAN controller. This is the brains of the entire solution. Controller is like the eye in the sky that manages the entire network. It monitors the entire network. It's responsible for even looking at traffic flows and then figuring out which path each appliance should take in case of congestion, things of that nature. And another element that I want to make clear is you can have either a cloud hosted controller or you can have an on-premise controller located within your data center. Now, your mileage may vary. Not every single vendor has both options available, Most of them have cloud-only option available, but you do have that ability to pick the right vendor. The final component in the SD-WAN architecture that is important to understand is the SD-WAN customer portal. Now, this is the portal that you use as a customer to configure the entire environment. You go in there, there's a one-time config that you typically have to do to get everything all set up, and then you also set up device templates, feature templates, different type of site templates. Just depending on the vendor, you have different, terminology, but you end up creating those templates for different locations. Like for data centers, you might have a separate template. For like sales branch offices, you might have another set of template. And then for the rest of your cookie cutter sites, you may have another template. So what you do is you create these primary templates, and then you just create a clone of those templates when you're trying to bring up new sites. And it makes the configuration a lot simpler to do. But the biggest idea here, guys, is we have this SD-WAN orchestrator that is in charge of everything. So in this scenario, we have two sites. What's going to end up happening is, assuming we have the templates already set up on the controller is going to instruct these appliances to apply a configuration, and that configuration being overlay tunnels, right? And then we have different type of policies within that, in terms of how we want the primary path to be picked versus the secondary path, or we might do active load balancing or load sharing across the two paths. And another piece I want you to be aware of from a terminology standpoint is that the circuits in the SD-WAN realm are called underlay. So you have the concept of underlay versus overlay. Overlay is the network we build on top of the underlay circuits that we may have. So you may have an internet circuit, MPLS circuit. We may have these circuits delivered via Ethernet, 4G, 5G, LTE, or you pick your flavor. It could be any of those combinations. And we can go ahead and build overlays on top. And regardless of the underlay, we can create different type of topology. So that's what makes SD-WAN so powerful compared to the traditional or old school WAN. Now, there are three big benefits of having an SD-WAN architecture. Number one, active design. So you get to utilize all of your circuits that you have in your environment. Most of the customers have two active circuits for redundancy, but then you also have some really large customers that actually end up having, maybe a tertiary circuit, right? Or maybe 4 circuits, or maybe even more circuits in their environment. Some of the vendors actually allow you to use up to 8 circuits in an active fashion. So that is really powerful compared to how in the traditional WAN we had to configure BGP in a really interesting and crafty way to be able to advertise routes in a certain manner and things of that nature. Here with SD-WAN, you don't have to mess around with any of those components. Another really interesting and awesome item is intelligent traffic steering. So now that we have this central intelligence controller that is managing the entire environment, it has this eye in the sky type of view, and it's able to steer traffic depending on the load on the network. Finally, all that translates to a better user experience. Now let's talk about a couple of items that I articulated in my SD-WAN architecture: private WAN versus public WAN. So let's talk about private WAN first, right? So when customer says I have a private WAN circuit versus a public WAN circuit, what does that mean? So let me demystify that for you. So let's say we have two locations, San Jose data center and New York data center. If we end up procuring a dark fiber circuit from our service provider, that would actually be a layer 1 dark fiber circuit. Now the beauty of this circuit is that it's fully dedicated. It's like as if we had literally a fiber optic buried in the ground between San Jose and New York. completely dedicated to us. Nobody else using that circuit. Now that is very cool, but at the same time, it's the most expensive type of circuit you can have because a service provider has to give you a dedicated infrastructure that is not shared with anybody else. So you pay premium top dollars for that. The next level up could potentially be a VPLS service, which stands for Virtual Private LAN service. It's a shared service within the service provider backbone, and you end up, getting a circuit from them. It could be a 10 meg circuit, 100 meg, gig, 10 gig, whatever have you. But VPLS is basically a giant layer 2 network. So all the sites that are part of the VPLS can actually exchange MAC addresses. Now that being said, typically there's a limit of how many MAC addresses each of your sites can pump into the service provider network because they have limitations on their provider edge and core, but that's a topic for another day. Keep things simple, it's a layer 2 circuit. Next level up could potentially be MPLS, which stands for multi-protocol label switching type of circuit. Once again, different bandwidths. But the bottom line is it's a layer 3 circuit. So here you don't do MAC exchange. Here you have to configure IP addressing on your customer edge routers in order to be able to communicate. And all of the sites that become part of the MPLS, you may have a full mesh set up so all the sites can talk to each other. But it doesn't have to be a full mesh. You can ask your service provider to set it up any way you want. Some people have partial mesh, some people have hub and spoke, whatever have you. And the other item, which is the other side of the spectrum, is the public WAN. And that is the internet. And it's layer 3 only. When you go to your service provider and you go, I want a public WAN circuit, they can only sell it to you as a layer 3 circuit. And there are 2 categories within public WAN. One is DIA. It stands for Dedicated Internet Access. It's the most expensive type of internet circuit you can get, but cheaper than MPLS or VPLS or the dark fiber, of course. Here, the infrastructure within the service provider network is shared. However, what's nice about the DIA circuit is that it offers business class SLA. So things like packet loss, latency, jitter, mean time to repair, meaning when things go down, your service provider will be able to get it all up and running within a certain time frame. There are all those promises made, and if they can't keep their end of the bargain, there are financial penalties, meaning they have to give you a discount on your service for that month if they can't meet their SLA. So it's pretty serious. Typically for my customers that have a really big operation, I recommend that they actually have DIA circuits at their key locations. DIA circuits are expensive, but at the same time, what I like the most about them is that they're symmetrical in nature, right? So if you get a 10 gig DIA, that's 10 gig up and 10 gig down. Now the next level below DIA is broadband. And broadband comes in different flavors. You got your DSL or cable or 4G, 5G type of connectivity. It's one step below DIA. Even if you end up buying quote unquote business class broadband, it's not much different than getting a broadband for your home. With broadband, you get best effort SLA. It's not nearly as good as the DIA SLA as far as packet loss, latency, jitter, mean time to repair, those type of things. You don't actually get anything fancy with broadband. The big plus is it's low cost. It's very cheap to buy broadband circuits. And what you get with broadband circuits is high download, low upload. Now for businesses, that could be an issue. That's why typically, at least at data centers, you would definitely want to get DIA type circuits, and then your branch locations, you can get away with buying a bunch of broadband circuits and kind of bundle them together and let the SD-WAN appliance do its magic. And that's the beauty of it. Now let's look at the cloud-friendly nature of SD-WAN. To explain that, let's look at the traditional or legacy WAN architecture first. So the existing WAN architecture for most of the companies that haven't upgraded to SD-WAN yet, you've got users located at a branch, and that branch has an MPLS circuit that takes you to the data center. And then the data center has a centralized internet access for your entire business. And as you can see here, the big challenge here is that the data center becomes a bottleneck because all of your users from all of your locations on a global scale will have to go to the local data center and then go out to the internet. It just kind of chokes that data center. Plus, typically you would have an MPLS circuit that would take you to the data center. So now you're clogging expensive MPLS bandwidth. It's a pure waste of money. However, if you were to take a step back and look at the connectivity needs of today, you have users at a branch that would need access to maybe an application that you designed in-house that sits in your data center. You might have other applications that are sitting in multi-cloud like AWS or Microsoft Azure. You may have some SaaS applications like SFDC or Salesforce.com and ServiceNow or Office 365. And you also need to be able to Google stuff, right? So you need access to internet. So the new WAN architecture dictates that we have a better way of doing business, and SD-WAN kind of lends itself to this modern WAN architecture. And it's simplified and secure. So what do I mean by that? So what we have is a single, centralized, cloud-delivered management dashboard for configuration and management of WAN, cloud, and security. With SD-WAN, regardless of the vendor you pick, you're going to have one place to go, and we call that single pane of glass, or SPOG for short. And you go there, that's where you configure everything. That's where you see everything. You have deep analytics about your environment. And you configure your WAN, your cloud settings there. You can also configure security through that portal. Now let's talk about a very important element of SD-WAN, and that's called Zero Touch Provisioning, or ZTP for short. The way ZTP works is step 1, we unbox and connect the SD-WAN appliance to the network. Step 2, the SD-WAN appliance calls home, talks to the SD-WAN controller. Step 3, SD-WAN controller pushes the config down to the SD-WAN appliance. Step 4, SD-WAN appliance joins the SD-WAN fabric. Thanks to ZTP, you no longer have to send highly certified engineers for deploying the boxes, right? So gone are the days that you would want to send CCIEs on site to be able to configure the boxes. Because we're doing everything centrally through a centralized portal, we can actually ship the box out, right? And a non-technical person on site can unbox the device and with very simple instructions, plug in the right cables and let the box talk to the SD-WAN controller and just become part of the SD-WAN fabric. This very step of not having to send certified engineers to every single site can translate to huge cost savings. Some of our customers have saved millions of dollars in deployment costs because they don't need to send an army of certified people everywhere. And that is amazing. And I think that's where SD-WAN shines. And another big important element is the standardized security. So what you get with SD-WAN is you can have what's called a local internet breakout, meaning each site has the ability to be able to access the internet directly without having to backhaul to a data center and then going out to the internet. So for example, here, if you look at the New York SD-WAN appliance, because it's got a DIS circuit, it can go directly out to the internet. And through the SD-WAN controller, we can push the security config down to the SD-WAN appliance in New York, so it has the right policy in place, right? It has the threat defense mechanism, next generation firewall, along with IDS and IPS and malware protection and all those things. Or we might have a scenario where we still want to use a centralized security model through service chaining. And what that means is when we use service chaining in SD-WAN, we can redirect traffic, in this case, internet-bound traffic, to a secure web gateway, or SWG, or a cloud firewall through a third party like Zscaler, and let them manage all the internet traffic at that point. So SD-WAN is very flexible. The bottom line is, regardless of the local or cloud security design you pick, you'll have a consistent policy across your entire WAN footprint. And this is a big one, guys, because I guarantee you, if you're not on SD-WAN, go and look at all of your routers today. Okay? You'll see that your devices have inconsistent configuration everywhere, different ACLs, different policies configured everywhere. Turns into a nightmare over time. Whereas with SD-WAN, everything is consistent, it's homogeneous, it's all the same everywhere, because we're pushing everything down from a centralized place. And every single appliance gets the configuration that we intend for that appliance to get. And that's the intent-based networking, right? Or IBN. And if you're interested in learning more about IBN, check out my video on the topic of SDN. And that's a wrap. Hope you liked today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.